But I think right now the hype train says, oh, this is where we're at today. And I think we're still years from that.
Automatically scares me. I have been telling people for 10 years, if they have an unlimited pot of gold, we can build them a manufacturing facility that they can wake up in the morning, they can turn on their smartphone, they can press a button, and it'll go. And we could, in theory, do that, similar to how we could, in theory, install artificial intelligence that can make in-process changes. But everything that can go wrong in any of those situations just scares me. If you're giving a machine that doesn't understand the process because the people that built the machine don't understand the process well enough, because I'm not sure any of us understand a process well enough to take a human out, and you're giving that the ability to go and accidentally make something explode.
Yeah.
That scares me. That's what scares me.
It scares me too. I think there are some processes and industries that lend themselves more to that. I mean, I've heard of lights out facilities, for a number of years now, right? It's not like it's impossible to do. I think, like the paper industry is one we work in a lot, right? I think there's so much that's not well known, coming in. Like, you have experts that know how to run a paper machine, but there's like this, one really critical piece of data. What is your chips, your chip quality look like? Hey, these logs sat in the field for a month, and then we brought them in, and then they sat at the bottom of the pile and got rained on for 3 months. And those are the chips I'm cooking today. Tomorrow, I take chips that I just got, they were fresh cut, thrown on the truck, freshly cut. Those are going to run differently, right? I've asked several pulp mill managers, do you even know which set of chips that you're running? No, they don't.
Never.
Right? Well, then you're going through the digesting process, washing, bleaching. You're going through several processes before it hits the paper machine. And then you've got people turning knobs, crew A, B, C, and D all turn the knobs differently.
Always.
Right? So there's all these like interrelationships that just create noise in a model. Okay? Now, I think that process is very difficult. Okay? I think, on the opposite side of that spectrum, you look at the drug makers, right? Pharmaceuticals. We know that Simca Online is doing some things in pharma, and I think some in the chemicals industry. It just kind of depends, but they are doing that kind of monitoring. And if they run, like, basically what the model does is it creates a tube, and if you keep your entire process in the tube, then you don't even have to do final product quality tests. You've nailed it. So it's not like it's unprecedented. Right?
I know people doing that.
Yeah, it's not that you can't do it. I think there's a lot of processes that are much more difficult to do it with. And, the first project we worked on, I remember telling the plant manager, I said, if you could have just let the process crash, we'd have a great model, right? He's like, well, Jim, I can't do that because it's literally a 7-figure problem if it happens, right? Or it could be. It's not always, but it could be. So you think about it, you can't let the process crash to get a good model. So what's going to happen is that the humans are going to tweak on it or stop before it crashes. It's kind of like, okay, well, what we have to do is let these self-driving cars crash to know, oh, we should have trained it differently, right? Well, that's fine, like on a test track in a controlled environment. We're talking about production facilities that are making hundreds of thousands of dollars, millions of dollars, a day, a week, a month. You can't just let it run into the ground, and we're gonna struggle to get our models right sometimes.
Yeah, I was gonna say, like, it's definitely, that's again the iterative process, that idea of can't let it crash, but we can get it when it starts to fail and start to catch those edge cases. And then you start to pick up other edge cases until you get a bigger, broader picture of what you're trying to do.
Yeah.
I think, you don't necessarily have to let it crash.
Right. Yeah.
Right?
Yeah.
But it takes time still to pick up, and then maybe that operator might not turn that knob so far the next time, and you pick up those cases. So, yeah, I think we can avoid some of those catastrophic things, or I know people do a lot of like planned, like, okay, we're gonna not do a crash, but we're gonna test something that we know specifically to see
A
how
design
it
of
behaves.
experiments. It's a
Exactly.
design of experiments.
A DOE.
typically. Yep.
And people will do a set of those if you have the opportunity to, but a lot of times
Correct.
people don't have that opportunity.
Yeah, that
So,
that
yeah.
really goes hand in hand, is because if you build a model and you start to find things that are causing the problem, right? You do a design of experiments and say, can I repeat this? Right? I'm not a design of experiments, expert. I know the term and I know the basic premise behind it. So please, if you're watching this video, hey, I'm going to go to Jim and have him help on DOE. We know people who can help you, but we're not it. But what we do know is kind of where it comes into play. That's a huge thing. I think one of the biggest places we could and should use machine learning and multivariate analysis is to help the subject matter expert eliminate ground. So I was at a facility probably, I guess it was in August, and we go by this guy's office. He's a subject matter expert, been there probably 20, 25 years, really intelligent guy, right? And I'll call him Johnny, right? That's not his name. I'll protect the innocent here. But Johnny they were a pie customer. Johnny had a process book screen up there, and there's probably 30 pens on the screen, right? I mean, there's just squiggles everywhere, right? And he's clicking through, and I'm like, Johnny, what are you doing? He said, oh, well, we've had such and such problem, and I'm trying to kind of understand what correlates with it. So let's think about this. So he's had a trend screen up, and he's trying to go back and find all the specific times where they had this specific problem, and look back before it happened, and he's throwing all these variables at it, and then having to build a bunch of these to figure out, does all this stuff line up? And I'm like, I really just took my head and kind of started beating the wall, like, no, don't do this, Johnny, please, right?
At least he was trying.
Oh, he's excellent at it, to be honest. He's great at it, right? And to be fair, he's a boomer. He's going to be retired in 5 years. Okay? These are the tools he's had. And, I'm not picking on Johnny, right? But what I said was, man, why don't you give us a data set, let us run it through Simca or one of the other tools that we've been playing with, and let's find out what seems to correlate and what definitely does not correlate. So then that way, instead of 200 variables that you're looking through, maybe we give you 20, right? Maybe we use event frames to you give us the conditions of when these things happened. And so we understand we narrow the field down of what we're looking at, as far as from a data perspective. Mm-hmm. And then we tell you, okay, these 20 things seem to potentially line up. And then you can do this analysis, right? Because we're going to need you to tell us anyway.
Yep.
So, that's where I think the benefit's going to be is let's eliminate ground, right? But then let's get the human back involved to see, okay, did we, find the problem? Did we find something that is correlative or could potentially be causal?